Bitcoin and other applications of blockchain. Chunk 19, Professor Massimiliano Sala, University of Trento. Monero. In this chunk, we are going to underline some perceived limits of Bitcoin, the pseudonymity, the non-egalitarianism. We will describe Monero, a new cryptocurrency that aims at overcoming these limits. And we will describe the CryptoNote protocol on which Monero is built. It was 1991 when criteria describing an ideal cash system were developed. 6 criteria. Among them, one can find independence, which means the security of the system cannot depend on any physical condition. Security. Cash cannot be reused or forged. Privacy. Possibility of performing offline payments. Transferability. Money can be transferred. And divisibility. In this context, privacy means payments should be untraceable and unlinkable. For each incoming transaction, all possible senders are equiprobable, and for any 2 outgoing transactions, it is impossible to prove they were sent to the same person. But observe that Bitcoin does not fully satisfy these 2 requirements. So it's not a full anonymous, but rather a pseudo-anonymous cash system. In general, the proof-of-work pricing function should not enable a network participant to have a significant advantage over another participant. So the Bitcoin creator Satoshi Nakamoto described the majority decision-making algorithm as 1 CPU, 1 vote, and used a CPU-bound pricing function, the double SHA-256, for this proof-of-work scheme. From recent example, one can see that a proof-of-work function used in Bitcoin architecture requires a parity between common hardware and high-cost devices. It does not possess this property, since mining is more efficient on GPUs and ASIC compared to CPUs. So anyone having specific ASIC has a significant advantage on the others. Therefore, Bitcoin creates favorable conditions for a large gap in the voting power of participants. As you can see in this picture, the rich and powerful and the majority of poor are there. Monero, XMR, is an anonymous and decentralized cryptocurrency based on the CryptoNote protocol. Monero uses a cryptographically sound system that allows you to send and receive funds without your transaction being publicly visible on the blockchain. So it's untraceable and unlinkable. Using the power of distributed peer-to-peer consensus network, every transaction is cryptographically secured, and your purchases, receipts, and other transfers remain private by default, preventing a blockchain analysis. Monero uses a special cryptographic technology called ring signatures. Ring signature shuffles the public keys of users in order to make it impossible to identify a particular user. Therefore, Monero employs a specific protocol which generates multiple unique one-time addresses that can only be linked by the payment receiver. It is infeasible for others to reveal them through blockchain analysis. And even if you use the keys of other users in the ring signature protocol, you do not need to cooperate with them. Hence, each participant produces a covered traffic independently. Monero's core is the CryptoNote protocol that wants to be a new approach to decentralize and emancipate cryptocurrencies. CryptoNote is a technology that allows the creation of completely anonymous egalitarian cryptocurrencies with untraceable payments, unlinkable transactions, double spending proof, blockchain analysis resistance, and egalitarian proof of work. The ordinary digital signature verification process involves the public key of the signer and terminates proving that the author possesses the corresponding secret key. Ring signature is a more sophisticated scheme, which in fact may demand several different public keys for verification. We have a group of individuals, each with their own secret and public key. The statement proved by ring signatures is that the signer of a given message is a member of the group. The main difference with ordinary digital signature is that the signer needs a single secret key, but a verifier cannot establish the exact identity of the signer. Therefore, if you encounter a ring signature with the public keys of Alice, Bob, and Carol, as in this example in the picture, you can only claim that one of these individuals was the signer, but you will not be able to pinpoint him or her. This concept can be used to make digital transactions sent to the network untraceable by using the public keys of other members in the ring signature applied to the transaction. This approach proves that the creator of the transaction is eligible to spend the amount specified in the transaction, but his identity will be indistinguishable from the user whose public keys he used in his ring signature. Your public key may appear in dozens of others in signatures, but only as a muddling factor, even if you already used the corresponding secret key for signing your real transaction. Moreover, if two users create ring signature with the same set of public keys, the signature will be different unless they use the same private key. Normally, when you post your public address, anyone can check on your incoming transaction, even if they are hidden behind this ring signature. To avoid linking, you can create hundreds of keys and send them to your payers privately, but that deprives you the convenience of having a single public address. CryptoNote solves this dilemma by an automatic creation of multiple unique one-time keys, ephemeral keys, derived from the single public key for each peer-to-peer payment. The solution lies in a clever modification of Diffie-Hellman exchange protocol, where the sender uses the receiver's public address and his own random data to compute a one-time key for the payment. The sender can produce only the public part of the key, where only the receiver can compute the private part. Hence, the receiver is the only one who can release the funds after the transaction is committed. He only needs to perform a single formula check on each transaction to establish if that transaction belongs to him. This process involves his private key, therefore no third party can perform this check and discover the link between the one-time key generated by the sender and the receiver's unique public address. One-time keys mean unlinkable transactions. Indeed, an important part of this protocol is the usage of random data by the sender. It always results in a different one-time key, even if the sender and the receiver both remain the same for all transactions. Fully anonymous signatures would allow spending the same funds many times, which of course is incompatible with any payment system principle. The problem is solved here thanks to a special property of the protocol. The special property is called linkability. If a user creates more than one ring signature using the same private key, these signatures will be linked together, which indicates a double spending attempt. To support linkability, CryptoNote introduced a special marker being created by a user while signing, which we call a key image. It is the value of a cryptographic one-way function, the secret key, so in mathematical terms, it's actually an image of this key. One-way property means that given only the key image, it is impossible to recover the private key. On the other hand, it is computationally impossible to find a collision, that is, to find two different private keys which have the same image. Using any formula except for the specified one will result in an unverifiable signature. So, all things considered, the key image is unavoidable, unambiguous, and yet it's an anonymous marker of the private key. All users keep the list of the used key images, compared with the history of all valid transactions. It requires only an insignificant amount of storage. And immediately reject any new ring signature with a duplicate key image. It will not identify the misbehaving user, but it does prevent any double spending attempts caused by malicious intentions or maybe software errors. So remember that Bitcoin's blockchain can be analyzed, the owners of coins can be partially identified, and money flow can be traced. Indeed, there are many academic papers dedicated to the analysis of the Bitcoin blockchain. The authors trace the money flow, identify the owner's coins, most of them at least, determine wallet balances, and so on. The ability to make such analysis is due to the fact that all the transfers between addresses are transparent. Every input and transaction refers to a unique output. Moreover, users often reuse their old addresses, receiving and sending coins from them many times, which simplifies drastically the analyst's work. CryptoNote is designed to mitigate the risk associated with key reusage and the tracing of one input to one output. Every address for a payment is a unique one-time key, derived from both the sender's and the recipient's data. As soon as you use a ring signature in your input, it entails the uncertainty. Which output had just been spent? Trying to draw a graph with addresses in the vertices and transactions on the edges, as you can see in the picture, one will get a tree, which is a graph without any cycle. because no key or address was used twice. Moreover, there are billions of possible graphs, since every ring signature produces ambiguity. Thus, you can be certain from which possible sender the transaction edge comes to the address vertex. Depending on the size of the ring, you will guess from 1 out of 2 to 1 out of 1,000. The proof of work mechanism is special. It's more like a voting system. Users vote for the right order of the transactions, for enabling new features in the protocol, and for the honest money supply distribution. Therefore, it is important that all participants have equal voting rights in the voting process. CryptoNote achieves this equality with an egalitarian proof-of-work pricing function, which is perfectly suitable for ordinary PCs. It utilizes built-in CPU instructions, which are very hard and too expensive to implement in special-purpose devices or fast memory-on-chip devices with low latency. Moreover, the required memory is an acceptable size for a modern ASIC pipeline. So there's no way to do any better than using your normal PC and vote with that. We can summarize what we learned so far. Bitcoin is one of the most important cryptocurrencies, but it is only pseudonymous and is not as egalitarian as claimed. The new cryptocurrency Monero overcomes these limits using the CryptoNote protocol that provides the cash system with untraceable payments, unlinkable transactions, blockchain analysis resistance, and egalitarian proof of work.